Hey there, and welcome. Today, we're diving into something that sounds super complicated, but is really the secret sauce behind everything you do online, the OSI model. And I promise, by the end of this, you'll see it's not some scary monster, but a really logical 7-story building that your data zips through every single second.
I mean, really think about it for a second. You hit send on an email, maybe in New York, and poof, it shows up almost instantly on a phone in Tokyo. That's not magic, right? It's this incredible feat of coordination between millions of different devices from thousands of different companies. So how on earth do they all speak the same language?
Well, it turns out they all agree to follow a universal rulebook, a standardized set of steps that make sure a message sent from literally any device can be understood by any other device anywhere on the planet. And that framework, that's the key to our entire digital world. All right, so here's our game plan. First, we're going to properly introduce this rulebook, the OSI model. Then, we'll follow your data as it gets prepped and routed across the globe. And finally, we'll ask the big question: why does this model still matter so much today?
All right, so this universal rulebook, what's it actually called? It's the Open Systems Interconnection Model, but pretty much everyone just calls it the OSI model. You can kind of think of it as the official blueprint for any digital conversation. So it was actually developed by the International Organization for Standardization, ISO. Now, it's really important to get this. The model isn't a physical thing you can hold. It's a conceptual framework. It takes the massive, messy job of network communication and just breaks it down into these neat, manageable parts.
And what's the magic number? It's just 7. That's it. This entire incredible process, from your screen to the other side of the world, is all organized into just 7 logical layers. Each one has a very specific job to do, and they all just stack right on top of each other.
Okay, so let's start at the very top, where your data actually begins its epic journey. Let's think of these first 3 layers as the sender's desk. This is where you come in, interacting with the network and getting your message all ready to be shipped out. So, it all kicks off at layer 7, the application layer. This is the part you can actually see and touch: your email app, your web browser. When you type out that email, you're working at layer 7. Then your data drops down to layer 6, the presentation layer. This layer is basically a translator. It gets the data into the right format, maybe encrypts it for security, and even compresses it to make it smaller. Finally, layer 5, the session layer, is like a digital handshake. It opens up a communication channel with the receiver and just makes sure that connection stays open and stable.
All right, our message is written, it's formatted, and we've got an open line. Now it's time to actually ship it. We're moving down to the next 4 layers, which is what I like to call the global logistics chain. This is where your data gets packaged up, addressed, and physically sent out into the world.
Okay, first up, layer 4, the transport layer. It takes your big email and chops it up into smaller, numbered chunks called segments. This is so it can be put back together perfectly on the other end. Next, at layer 3, the network layer, each of those segments gets tucked into a packet. And get this part's super important. It gets stamped with the final destination IP address. That's the full global home address. Then, at layer 2, the data link layer, that packet gets put into yet another wrapper, a frame, which has a more local address, just for the very next hop on its trip. And finally, we hit rock bottom, layer 1, the physical layer. Here, that frame is turned into nothing but a raw stream of zeros and ones, sent out as electricity, light, or radio waves.
So, you might have noticed the name for our little piece of data keeps changing at each step. The fancy term for this is its Protocol Data Unit, or PDU. It starts out as a segment, kind of like numbered pages of a letter. Then it becomes a packet, like a sealed envelope with an address on it. Finally, it's put into a frame, which you can think of as a shipping container ready for the next truck. Okay, let's really nail down this point, because it's crucial. The 2 different kinds of addresses. The IP address from layer 3, that's the big picture, the final destination, your friend's complete home address over in Tokyo. But the MAC address from layer 2 is just for the very next immediate step. It's like telling the mail carrier, just get this to the next post office. You absolutely need both to get the packet all the way to where it's going.
And of course, once those signals finally get to where they're going, the whole thing just happens in reverse. It's pretty elegant, right? The receiving computer grabs the bits at layer 1, rebuilds the frames at layer 2, unwraps the packets at layer 3, pieces the segments back together at layer 4, and on, all the way up to layer 7, where your email appears, perfectly reconstructed.
All right, so that's the theory. That's how it's supposed to work. But that brings us to a really important question.
In our world of crazy fast internet, is this old model, obsolete?
And the honest answer is, well, kind of. See, the internet we're all using right now isn't a perfect, strict version of the OSI model. It's actually built on a leaner, more practical 4-layer model called TCP/IP.
So that leads to the big question, right? If we don't technically use it in its pure form, why does every single person in IT, networking, or cybersecurity have to learn the 7-layer OSI model? Why are we even talking about it?
Well, the answer is all about its power as a tool for learning and for fixing things. One of our sources for this explainer, Geeks for Geeks, puts it perfectly. The OSI model is still very helpful for solving network problems. It helps people understand network concepts very easily. At its heart, it just gives us a crystal clear way to think about how networks operate.
And this is really where the OSI model shines today. First off, it's a universal language. Tech pros can talk to each other and know exactly what the other means. Then, when you're troubleshooting, you can isolate the problem. Is the cable unplugged? That's a layer 1 problem. Is a website address not working? That might be a layer 7 issue. And maybe most importantly, it's still the absolute best conceptual map for really understanding how networks work, from the ground up. So, from now on, whenever you send a message, load a website, or stream a video, just take a second to picture that invisible, lightning-fast journey. Remember, it's not just one thing happening. It's this incredible, perfectly choreographed 7-layer dance of packaging, addressing, and sending. Now, can you see that hidden 7-story journey behind every single